Let's go.
So, hello, Amr. Let's start right away. Amr, you and your team won first place in the Huawei Cloud Competition in North Africa. Out of hundreds of teams, how does that feel?
It's still great when I say it for loud. 389 team across North Africa, and we came first. We were we were the first Egyptian team to overwin the competition. It's not just personal; it's a historical moment for my country, Egypt. Egypt's Ministry for Higher Education officially recognized it, and it was covered in more than 25 major news outlets. But the thing that means most for me wasn't just the rank, it was a specific award, the best architecture award, given directly from the Huawei owns principal architect, the person evaluates system for living. They have seen hundreds of production architecture for them to look at what we built and say, hey, this is the best architecture here. This is a real technical judgment, not a participation trophy. And I want to put this in full context. I did all of this while I am still a third year computer science student. I haven't graduated yet. So, yes, it feels good. But more than anything, it feels like proof that I'm moving in the right direction.
Absolutely. If you had to describe yourself in one sentence, what kind of engineer are you?
I build infrastructure that doesn't need a human to babysit it. That's a honest one sentence version. Everything I design, pipelines, cloud environment, security checks, is built to run it on its own, catches its own problems, and recover without someone manually interventing. My measure of success is if I disappear for a week, does the system hold?
Great. That's a good sentence. Why are you interested in cloud computing, DevOps, and infrastructure right now?
I think because the problem is everywhere and most of companies haven't solved it yet. Every serious company in Germany or Wallet right now, fan company or mid-size companies in Munich, Frankfurt, Berlin is dealing with the same challenge. How do you migrate to the cloud without breaking things, slowing your team down, or opening security holes? This is exactly the problem I have been solving hands-on for the past year. Not a theory, not a course exercise in actual projects with real pipelines, real infrastructure, and real security gates that block the deployment when something is wrong. I also choose this field because I didn't just ask, does the feature work? I ask what happens when it's break at 3 a.m., who gets notified, and how fast does it recover? This mindset is not something everyone has. It's what infrastructure work is actually required.
Sounds great. When did you first realize that you were fascinated by the cloud and infrastructure?
It's happened in my first year at Alexandria University. Everyone around me was focused on writing code, apps, websites, scripts. I keep asking different questions. Where does this code actually run? Who configures the server it lives on? What's happened when it's crash at 2 a.m. and no one was watching? No one in my class was asking those questions. That gap pulled me toward infrastructure. The first time I created virtual machine, configured network from scratch, and got two servers talking to each other, I realized that is what I actually want to understand, not a layer top of it, the foundation underneath everything.
I know I'm repeating myself, but sounds great too. Many developers write apps. You build infrastructure. Why?
I believe it's because apps are physical. Everyone sees them, everyone uses them. Infrastructure is invisible until it breaks, and the moment it breaks,
True.
nothing will. Not the app, not the business, not the user. Everything stops. I think infrastructure engineers carries more responsibilities they if are given credit for. the
Mhm.
architectural decision I make today, how services talk to each other, how secrets are stored, how deployments are gated. Those decisions are running in background silently for months, even years. This is interesting for me. There is also a creative dimension to that people don't expect. Every cloud environment is a puzzle with a real constraints, budget, latency, security, requirement, scalability need. Finding the architecture that satisfies all of them at once is generally a creative problem, and I
Mm.
enjoy this kind of thinking and the problems.
Nice. What was your experience like at Alexandria University?
It gave me the foundation, computer science with cybersecurity minor, solid academic ground. But to be direct, most of important learning happens outside the classroom. I started getting certified in my first year. The IC2 is certified in cybersecurity, Cisco Cyber Ops before I even finished year one. Then I moved to the cloud, my Azure Fundamental EZ900 and my Microsoft Certified and Compliance CS 900 and Microsoft
Mhm.
Administrator EZ104. Then AWS Solution Architect. I didn't wait for a professor to guide me there. I watched where the industry was going and I moved to it from for on my own. But the university did give me something I didn't expect. The team, the engineers, I competed with them in a Huawei Cloud Developer Competition where people I met in Alexandria University, the team and the chemistry between us, winning with those people was the most valuable thing the university gave me.
Nice. It's all about the team.
Yes.
Was there was sorry. Was there a particular moment that had a big impact on you?
Yes. My Google Cloud Engineering internship in summer 25, I was working on a real fraud detection system or deployed in Google Cloud Run. My task was to optimize the container cold start. The container was taking 5.3 seconds to start. I analyzed the profile, refactor how build caches layers were organized, and I make it multi-stage build and brought it down to 3.2 seconds.
Okay.
That 40% improvement on production system. It's not a demo, it's not a toy project. That moment removed all doubt from me. I was just I wasn't just studying cloud engineering anymore. I was doing it in professional level with a real measurable impact. This difference in feeling, and once you have it, you don't steal for anything else.
Absolutely. Your oh my God. Wait, just give me one sec. You're currently working on a 5-tier DevSecOps migration to AWS. Can you briefly explain what you've built there?
Terraops is a project I built from scratch to cover a full migration journey of a real enterprise application, a Java application with 5 components. It's Nginx for front end, Tom end as a back end, MySQL database, Memcached for caching layer, and RabbitMQ as a message broker.
Mm-hmm.
The idea was to migrate it to AWS across 4 progressive stages. Each one is more automated and more secure than the previous. In stage one, I replace all manual environment setup with background and bash scripts. Who talks me 16 minutes by hand? Now it takes 10 minutes with 100% usability, no human error possible. And it's simple because the setup is scripted and documented. You don't have to remember the command or what you first do, what the next. No, no, you only run the script. It takes care of everything. Stage two, it's full AWS lift and shift. I provisioned more than 100% across the availability zones using Terraform. I built a complete CI/CD pipelines, GitHub Actions to Jenkins, SonarQube to Nexus, to Tomcat, OSP security scanning as a hard deployment broker. I also added Prometheus and Grafana for observability and Slack alerting for notifications for stakeholders. In stage three, I moved from self-managed to fully AWS managed service, Redis Elastic Cache, Amazon MQ, Elastic Beanstalk, deployment time. dropped from 45 minutes to under 10 minutes with zero downtime.
Oh, wow.
I added, I adding also the best part is here. I adding also a DevSecOps as infrastructure as a code security and truffle hub, a secret detection as security gates scanning on at commit time, not at build time, at commit time. The stage four was a fully containerized with Docker, Ansible orchestrator deployment with zero manual SSH. You don't have to SSH. Then I moved to ACS Fargate. It's a serviceless infrastructure cost cut from 5 EC2 instance to one with zero credential in the code. It's fully visibility through a Datadog APM metrics.
That sounds big. What was the biggest technical challenge?
I think making security as hard problem, not a warning, not a report, not a
Mm-hmm.
checkbox, an actual step. In most pipelines, security tools run and they produce reports. Someone adds it to backlog. Maybe it gets fixed in 2 weeks. Maybe it's not. Maybe never. In my pipeline, if a Trevi and it's a image scanner find a critical CSV in a Docker image, that image does not got be published to the registry. Of if OSAP, a dependency check, finds a vulnerable library, the build stop right there. If a TFSec as a infrastructure security as a code scanner finds a misconfigured IAM policy in a Terraform code, nothing gets deployed. Getting those gates to work reliable without slowing down the pipeline or generating a noisy reports for a team is took a real work. You have to define exactly which is a 30 level trigger, which is a warning. You have to handle false positive too, intelligently, of course. So this balance is harder than it sounds.
Wow. A lot of technical things, but you
Yes.
understand what you're talking about. That's all I need. How did you use Terraform and CI/CD there?
Terraform was the backbone of entire infrastructure. Every
Mm-hmm.
single AWS resource was provisioned through code. 300 plus resource across the availability zones, VPCs, subnets, security groups, EC2 instance, load balancer, Redis databases, IAM roles with listed privilege policies, Route 53 private DNS, SSM private store for secret injection. The rule I held myself to, if I had to click anything in AWS console to set up the environment, I failed.
Mm-hmm.
Everything must be in code. That means if someone deletes the entire infrastructure today, I run one command and it comes back exactly as it was. Every resource, every configuration, every permission in the same day.
Mm-hmm.
So the real value of Terraform is not just the automation, but it's a total confidence that your infrastructure is reproducible. For CI/CD's continuous integration and continuous deployment, the pipeline was GitHub Actions and
Mm-hmm.
Jenkins. I also used AWS Code Build running through SonarQube for good quality, and the next is a private artifact store deploying to Tomcat as a backend, with every security scan running as a mandatory gate at each stage. Code that fails that don't move forward.
Hmm. DevSecOps means security from the start. How do you put that into practice?
The core idea is a security problem found at commit time cost almost nothing to fix. The same problem found after the deployment can cause everything. So I try to move every security check as left as possible, as close the moment the developer writes code as I get.
Mm-hmm.
In practice, there are what I looks like in my pipeline at commit time. Travel Hub, security, a scanner for infrastructure as a code, scan for secret accidentally left in code, API gateways, maybe passwords, token. It's caught before it even reaches the repository. At infrastructure, right, TFSec, scan every Terraform file for misconfiguration public S3 bucket, overlay permission IAM rules, unencrypted storage before the infrastructure is actually created in the cloud.
Mm-hmm.
At the build time, the Travi, a container scanner, scan for Docker image for known CSVs in the base image, and every installed package. Critical files blocks a push to the registry. As a deployment, an OSAP dependency check scans all the third-party Java libraries for known vulnerabilities. A failed check stops the deployment. None of these produce reports go to the backlog.
Mm-hmm.
They are gates. Security is not a phase, it's a property of every artifact that moves through the pipeline.
Hmm. Many people talk about the cloud, but what does that actually mean in practice?
I think in practice, the cloud means you stop managing machines and start managing outcomes. And instead of asking how many servers do I need, you ask what does the system needs to do and how do I make it more cheaply and automatically. In my Ops project, I provisioned over 300 AWS resources, load balancer, databases, message queues, DNS records, IAM policies, all through Terraform. We built it from scratch in about 10 minutes, if needed.
Mm-hmm.
No racks, no cable, no physical data centers. It's all in the cloud. The other thing that cloud is actually means in practice, you can measure everything. I know exactly what each component costs. I know latency between servers. I know when something is about to fail before it does, because Prometheus, Grafana, and AWS Cloud Watch are watching every metric in real time. This level of visibility does not exist when you're running a physical server in closet somewhere. So the
Mm-hmm.
cloud is not a destination. It's a way of engineering that force you to be sure about every decision.
You and your team beat 389 other teams. What did you build?
We build Volnera, a cloud-native cybersecurity platform running on Huawei Cloud. The architecture was a three-node Kubernetes cluster on Huawei CCE with layer 7 load balancer. We built a full good RCI/CD pipeline enabling zero downtime deployments with a controlized microservice. That pipeline got releases cycles by 85% compared to manual deployment process.
Oh,
So
wow.
yes, good. The core feature of AI is an AI-powered threat intelligence engine using Huawei Model Art, processing and analyzing security events in real time, with finding persistent in Postgres SQL database. IAM access controls were enforced at every layer, which we calculated reduced operational cost by 40%. My specific responsibility was the overall architecture because I am the cloud architect in the team and the Kubernetes infrastructure, of course, how the cluster configured, how servers communicated, how traffic was routed, how deployments were orchestrated also. This is why the Huawei principal architect gave me Specs Architecture Award specifically,
Oh,
not for the
congratulations.
thank you. It's not for features, it's not for presentation, it's for architecture itself.
Great. What made your project better than the others?
I believe the honest technical answer was we built it for production, not for demo. And now we are in CNCF mentorship process also. In competition, most of team build something that work once in the right environment with the right configured perfectly, impressive to show, good to run. We built something that would survive in a production environment, in a real environment. Proper
Mm-hmm.
Kubernetes orchestration with health check and rolling deployments, a CI/CD pipeline with zero downtimes, AI integration with persistent storage and cost controls built into architecture from day one. It's enterprise level. Huawei principal architect was evaluated a lot of testing. They can tell the difference between something was built to look good in presentation and something was built to actually run. And this is Volner.
Mm, fire. What did you learn from this experience?
Two things I didn't expect to learn. First, clarifies that the actual competitive advantage under pressure. When the deadline is real, teams that over-engineer architecture collapse under weight of their own decisions. We made every architecture choice early and documented that reason. When Huawei architects asked, why did you choose this approach? I have a direct answer every time, no
Mm-hmm.
hesitation. This consistency across the whole team, what was separated us. Second, the engineering leadership is about ownership, not control. I was a team captain for engineers, tight timeline, different streams. My job was to make sure the architecture was clear enough and each person could get deep in their area without waiting for
Mm-hmm.
me. When everyone knows exactly what they are responsible for, the team moves fast and produce a clean work. Most of the team didn't got it right. We did.
Fired. Great. I like this confidence. What does teamwork in engineering mean to you?
I think it means clear ownership above everything else. The worst thing that can happen in any engineering team that two people working in the same thing without knowing it, or one person waiting for permission to move forward in something that clearly is a responsibility. Both lose the team and make it down. In our competition team from day one, everyone had a defined area. I owned the architecture and Kubernetes. Every person had their pieces. We collaborated in the design phase, make sure that the, our pieces fit together. That integration was smooth because the interface were clear from the beginning.
Nice. Let's talk a little bit about personality things. How would you describe your approach to engineering?
I believe it's three principles I apply to everything I build. First, automate first. If I do something manually twice,
Hmm.
I write script for it. The third time should not be manual. This is not about efficiency, it's about being reliable. An automated process does not make mistakes because it's tired, distracted, or skip process. Maybe human does. Second, observe everything. Every system I deployed has a monitor from day one. Prometheus, Grafana, Datalog, AWS CloudWatch, whatever fits the stack. If
Mm-hmm.
something breaks at 3 a.m., I want to know it before the user does. And I want to know exactly what broke, why, and which alert is fired. You cannot fix what you can see. So the third, secure by default. I study cybersecurity. It's my life. So secrets go to the secret manager from the beginning, not after someone flags it in review. I am policy rules get a least privilege from the Terraform file, first Terraform file I write. Security scans then every pipeline. These are not things I added when I have a time. These
Mm-hmm.
are the starting points from
Hmm.
every project I made.
Mm-hmm. What motivates you most about technical challenges?
The shift, the moment between that was broken, slow or manually, become clean, automated, and reliable.
Mm-hmm.
When I cut the deployment time in my project Strata-Ops from 45 minutes to under 10 minutes with zero downtime, this was not just a performance matrix. It was a real challenge in how a team can work.
Mm-hmm.
Nobody has to sit and watch deployment anymore. No one has to SSH and check if it works. It runs, it verifies itself, and it alerts if something goes wrong. This kind of shift from chaos to order is satisfying to me.
Mm-hmm.
I also find the harder problems sharpen my focus rather than overwhelming it. When a challenge has a real constraints, budget, security, performance, reliability, all at once, that's why I do my best.
Great. What sets a good engineer apart from a great engineer?
I believe ownership over the full life cycle, not just a build phase. A good engineer delivers a feature. A great engineer asks, what happens when this fails at 2 a.m. on Saturday? Who
Mm-hmm.
gets notified? How does it? How fast does it recover? Can a
Mm-hmm.
new team member understand this in 6 months? Is it going to cost the company more than it should in the next 6 months from now? Great engineers think in systems. They care
Mm-hmm.
about what happened after they push a commit. Their code is reliable because they know someone else will read it. Their infrastructure is documented because they know someone else will have to maintain it. Their monitoring is meaningful because they know someone else will be called for it. This is a standard I try to hold myself to, not just does it work, but does it work securely, efficiently for anyone at any time without needing supervision.
Mm-hmm. Makes sense to me. With so many technologies out there, how do you keep learning?
My approach to I pick one thing, go deep, build something
Mm-hmm.
real with it, and then move forward. This is the full method. The trip, I think the trip most people fall into that they collecting tools without understanding on any of them deeply. I can speak for Terraform specifically with details because I use it to provision more than 300 real AWS resources across multi-EZs from scratch. I can speak for Kubernetes because I built a three-node Kubernetes cluster from scratch and run a controlized microservice on it in the competition with a real judgment. The
Mm-hmm.
My new certificate, certified Kubernetes administrator I'm preparing for right now, will push this knowledge even deeper. The certifications forces me to cover all parts that maybe otherwise I skip. My
Mm-hmm.
certifications, AWS Solutions Architect, Associate, and Azure Administrator Certified, helps me to structure what I learn and validate it actually covered the full scope. But always the real test is, can I use this to build a real project under real constraints and produce something that works in production?
Mm-hmm.
And I can.
Great. That's what I want to hear. Um, so let me have a look. What is missing? Obala. How do I get there? No, it's my mistake.
Are we
Ah,
good or
we're good. I will cut this scene out.
okay?
this,
Okay,
but just when we're talking, um, I find it very good. Real, real talk.
thank
I'm
you.
surprised that the first try is going so well.
I learned from the best.
So, let's go on. Let's call it vision and future. You're currently
Okay.
looking for a mandatory internship, like Pflichtpraktikum, in the cloud DevOps field in Germany. Why Germany?
Because Germany is where a serious engineering is treated seriously, and that is exactly the environment I want to grow in. I am not coming for lifestyle. I coming because Germany has this specific industries I want to work on, automotive infrastructure, industrial systems, enterprise cloud migration at scale, fintech. There
Mm-hmm.
are sectors where misconfigured pipeline is just a performance issue. It can be self issue or regulatory violation. This level of project route engineering is exactly what I want to be part of. Germany and the broader tech market
Mm-hmm.
also has something the Egyptian market not, does not yet have at scale. Large established companies with a real cloud infrastructure challenges and the budget and disciplines to solve them properly. I want to work on problems at scale.
Mm-hmm.
And from practical standpoint, my internship status means that is not visa complexity for the company, no work permit application, no sponsorship process, one learning, one standard learning agreement, three signatures from my university and
Mm-hmm.
me and the company, and I handle the entire visa process at the embassy in Cairo independently. So it's zero HR overhead for company.
Sounds good to HR, I would say. um, in what kind of environment do you think you'd learn the most?
One was real problems, high standards, and direct feedback. I don't get hand holding, and I don't need an easy task. What I need is this: an infrastructure that actually matters, real constraints, and
Mm-hmm.
engineers around me who cares enough about their work. A team where a good enough is not acceptable. We
Mm-hmm.
are someone looks at my Terraform code or not, then say, "Hey, this IAM policy is too open. Rewrite it." This is the
Mm-hmm.
environment where I improve fast. I also work well independently. I look at system, find the gaps, and go after it. Nobody assigned me Terraops or Kubernetes cluster or FineOps Sentinel I built it because I defined something is missing in my own skills and
Mm-hmm.
I want to fix it.
Mm, good. What kind of problems would you like to solve for a company?
Three categories specifically because there are the ones I have already worked on. Infrastructure that is still largely manual. Companies where deployment require a human step, uh, where environment can be reproducible from a code, where is there no single Terraform file or Ansible automation that describe what actually running. I solve this
Mm-hmm.
pattern and I won't solve it at enterprise scale. Security, treat it as a final review, not a pipeline property.
Mm-hmm.
Organizations where a vulnerability reports sit in the backlog for weeks because they no automated gates for forced to resolve it. The cost of embedded security is always higher than build it from the start. I know how to build it from the start. The cloud cost is nobody fully understand the cloud cost. Resources running that nobody reminds to provision budget without no attributions, no visibility is what actually being spent where. I built a fine ops Sentinel and Azure. It's an event-driven cleanup engine that targets $2,000 per month in potential savings across 15 flagged resource that kind of problem is visible, measurable, and completely solved with the right tooling.
Wow. Where do you see yourself as an engineer in the future?
In 4 or 5 years, as a senior cloud security architect, who makes architecture decisions, not just exercise tasks, someone who can walk to company infrastructure from outside, understand it quickly, identify the risk and influences, and design credible paths to fix it. This professional
Mm-hmm.
level I am building toward. Longer term, the principal architect track interests me. The best architecture award from Huawei
Mm-hmm.
principal architect that here to me showed that the role is likes when it's doing well. Someone who evaluates many different systems with constraints standards and gives direct, accurate technical judgment. This
Mm-hmm.
rule I want to grow onto it over the next decade. But right now, the next step is clear. Get inside a German engineering team, work in reproduction infrastructure, contributed immensely from the first week, and learn what the cloud architecture looks like at enterprise scale in European market. This is what my internship is looked for.
Mm-hmm. Let's uh, let's come to let us come to the end. Um, what kind of team are you looking for?
A team that builds real things and holds itself for real standards. I am
Mm-hmm.
not looking for a place where I shadow someone for 3, 4 months and I leave a certificate. I want to contribute from the first week. Writing Terraform, reviewing pipelines configuration, setting up monitoring for a new service, whatever its actual needs is. I have a technical foundation to do it. I don't need a warm period. I work
Mm-hmm.
best with direct communication. German engineering culture is known for being straightforward. This is not a culture shock for me, it's a preference. Tell me what is wrong in my work specifically, and I will fix it. The IAM policy is wrong, say it, and I tell you why, and I show it how to improve it.
Mm-hmm. If a company sees this video, why should they hire you?
Good question. Let me be direct about what I am because the combination is unusual. I am a third year computer science student who holds the most two professional cloud certificates, AWS Solutions Architect Associate and Azure Administrator, the most working professional only attempt after years of full-time experience. I completed a engineering internship at Google Cloud here.
Mm-hmm.
I captained a team that beat 389 competitors in regional cloud architecture competition, earned the best architecture award from Huawei's own principal architect, and was recognized by Egyptian Ministry of Higher Education. I am currently preparing for Certified Kubernetes Administrator. I have built, not studied, I not watched the tutorials. I built a 5 stages AWS migration project with a real CI/CD pipelines, real security gates that blocks deployment, real infrastructure as a code, and real production monitoring. Every climb in my profile has a number behind it. 40% cloud start reduction, 300
Mm-hmm.
plus Terraform resource, 85 faster release cycle, $200 per month in cloud cost saving
I think it was
identified
2000,
and
wasn't it?
surfaced. No, 2000 per
Yeah,
month, yes,
you
in the
see.
cloud cost savings.
Yeah.
Identified and so this is actually identified who I am. From the process standpoint, my internship means your company signs one learning document. That's it. I handle the visa, I handle the embassy, I handle the paperwork. You get a certified production experience cloud engineer for internship period with none and any administrative complexity that usually comes for with international candidates. I am not seeking for a chance to eventually prove myself. The
Mm-hmm.
proof is already there. I am asking the right environment to put me in the work. That's who I am.
That was a good closing. Let's find an internship for you.